Yeah, I hope you've all had a great day so far with our amazing speakers. I'm Johannes, I'm one of the co-founders at meshcloud, and I want to talk for hopefully just the next half hour. I like to talk a bit longer usually. About platforms of the future. So why are we even talking about platforms? So you know how this goes, right? At the beginning of time, we had two silos, dev and ops, and we threw software over the fence to ops, and as a thank you, we got tickets back if it didn't work. And because we did not like that, we gave tickets back to ops to just give us more hardware and more resources. And then someone figured out that this is not the smartest way of shipping software, and the idea of DevOps was born. We put those two teams together. We can go through the cycle of developing and shipping software a lot faster. Well, there's an asterisk on it because the way it was meant in theory was very nice, but in practice it usually meant we'll just let the full stack devs that have trouble keeping up with JavaScript frameworks also keep up with Kubernetes. That's obviously a great idea, so now we're going to do 3 silos. We'll just put a platform team in between the dev and the ops team, okay? So that's why everyone's talking about platforms now. So before we talk about platforms of the future, maybe it's a wise idea to look at the elders and figure out what platforms of the past got right and wrong and try and learn from that. The probably original platform that everyone thinks about when we go through the classic cloud pyramid of like infrastructure as a service, platform as a service, and software as a service was Heroku. Heroku came out of the Ruby ecosystem sometimes around 2008. And it promised something very simple. You just install a CLI tool, you get a Git repo, you push to that Git repo, it builds your code and hosts it on a website. And you could go from like code on your machine to a working website in like less than 5 minutes. And frankly, at the time I was around back then, that was magical. And if you needed a bit more, like you needed a custom domain or you needed a database or a memcache, whatever, it was just one CLI command away. And the interesting bit about that user experience or that developer experience really is about all of the things you did not have to do, right? No servers, no load balancers, no DNS, no networks, just writing code because that's what software engineers are supposed to do, right? And not keeping up with Kubernetes. So let's look at what Heroku did very well. Gregor Hope, who's a very well-known enterprise architect and has written books like The Enterprise Architect Elevator and a good book on cloud strategy, has this year also published a book on platform strategy, and he says that good platforms have like 5 properties to them, and Heroku did 2 of them very well. The first one is that platforms need to accelerate. They need to accelerate innovation, they need to enable users to focus on the stuff that differentiates versus like doing all of the boring stuff. So for software engineers, that means writing code and not managing servers. And the second angle that Heroku did also very well, because they had a generous free tier that probably lots of people here that were around at the day have also used, is they democratized access to the platform. Like it was very easy to get started, and if you wanted to host something in production, it was a couple dollars a month to get started. And that's 2 parts of these 5 properties that Heroku did very well. And let's abstract that for a moment, right? So if we want to build a platform, what do we have to do, right? So our goal is that we want to build applications. That's where, for our business, the differentiation is, right? That's where you win in the market. You're not winning unless you're a hosting provider, right? That you manage servers better than anyone else. You win in the market by building better apps for your users. And all of the complex engineering, we try to get away from the application team and put into a platform. And that means that we need to provide some services on the cloud, and to do that we need a control plane that kind of does all of the provisioning and deprovisioning and security and all of that boring stuff. And we need a console for the users because somehow they need to interact with the platform. Sounds very easy, right? We just have to build 1, 2 boxes and maybe that one as well. And in fact, that's what from like 2010 to 2015, 16-ish, in fact, many people try to do. And of course, you're not trying to do everything from scratch, but like the good software engineers that we are, we'd first try to figure out if there's something open source that does it already, right? So that's where OpenStack, which was mentioned today, I think a couple times already, and Cloud Foundry is just 2 examples of like platforms, open source platforms that were around before Kubernetes was popular, were born, and people were thinking, hey, we can put that onto the hardware that we have in the basement, and then we'll have a cloud platform in-house, right? What could possibly go wrong? Well, it turned out that this complex engineering was indeed very complex. So many of these initiatives had technical challenges that were very difficult to overcome, and a lot of projects that were started with high ambitions led to, let's say, medium outcomes, right? Yeah, that was certainly very challenging. So what has changed since then? Well, I was talking about the technical complexities that we have in here, and that ultimately made it very difficult for people to work on shipping a developer experience like Heroku did, because they were stuck in the technical details. But Heroku had another problem to it in the way that it was built. And that is the third capability or property of a good platform that I want to talk about. And that's that platforms should not constrain their users in what they can build on top of the platform. And that needs a bit of explanation. Heroku had that model where you could push your code, and it was great for building anything that was stateless. They had this model of, they called it like a 12-factor app, where you would separate the components that needed state from those that didn't need state, and then you could scale all of the stateless components very easily, and inject config via the environment, and all of the stuff that we nowadays think of as like cloud-native architecture, right? They were the pioneers of that in many ways. And it turns out that this model was indeed very constraining, because there was a lot of workloads that you just could not run on this type of platform. You could only essentially run the new stuff that was like specifically built for it on top of it. But if you needed anything that holds state, like a custom database or a message queue or like some sort of business logic service that needs to hold state, very, very difficult to run on top of this platform. Right. And by, about like 2015, 16, something entered the picture like with great popularity that solved that, and that was containers, right? Containers gave us a new interface between developers and operations people for how we package software and declare its dependencies, not just in terms of the libraries and stuff that it needs, but also in terms of like network ports and file systems and all of that stuff. So they have become like a better abstraction, really. And as soon as we had containers, we needed container orchestration platforms, and that's where Kubernetes came about. And you can see that in early 2017, there was kind of like this inflection point where the popularity of both DevOps and Kubernetes overtook like what Heroku had, and like that's where the point probably in the market where these things were kind of like decided that Kubernetes is going to be that like platform of the future that everyone builds. And you can see that the trends go like kind of hand in hand. So I guess out there's many people that confuse Kubernetes and DevOps, because that's what it means in layman's term. If you ask your managers, that's probably the answer you'll get. So where does it leave us? So imagine we're trying to build a platform from like somewhere in between 2017 and now. So how do we build the platform today? So well, maybe we'll just use the public cloud to do all of the complex engineering for us, and we'll use Kubernetes as the way to provide the services. And in fact, that approach is much more successful, because even with a small platform team, you can come up with a working platform a lot faster. There was only one problem. Now that we techies solved all of the technical problems in a reasonable amount of time, we suddenly had to face all of the organizational problems that come with it. How uncomfortable, right? So, how do we do that? Well, maybe we get back to the tech stuff that we love, right? We have these beautiful landscapes of all the tools, and to this day I can confidently say that I have still no clue if it's better to run my Kubernetes on Cilium or Flanell or Calico. So what did we end up doing, right? We just use whatever GKE uses, or AKS or EKS, and I have actually no idea what it does, which is great if you think about it. But we also got another problem. Now that we run in the cloud, we somehow have to figure out how to use the cloud in an enterprise context. So we need things like landing zones. And it turns out they're not as easy as the cloud providers will make you believe when you start your journey on the cloud. They will give you this beautiful diagram of like, hey, this is the Azure Enterprise Scale Reference Architecture, and you just have to build that. And it's one Terraform module that you can deploy. It does all of that in 45 minutes, Felix, I believe. That's how long it usually takes, if it works at all, because we're talking Azure. So, okay, so lots of complexity in there. Thankfully, there's cool companies like meshcloud that help you solve that. So we can now talk about platform design and talk about the users of our platform. So, platform design. Wait a minute. Actually, platform engineering is interesting. You see, we call it engineering, platform engineering. We're still talking about how to build these platforms rather than talking of why we built them and for whom we built them. So, I'm afraid I will actually be talking about designing and not so much about the engineering. Because if I was talking about the engineering, I could tell you, this is also from Gregor Hope, like a nice architect view. This is all of the things that your platform will need: a management plane with a user interface and an API, and automation language integration like Terraform, a service catalog, and orchestration, and user management, operations UI, cloud services integration, and an interface to build your own services. And I could tell you just buy Meshstack and it solves all of these problems for you, but I want to talk about platform design, right? So, let's look at a software that probably everyone knows. Who can explain to me in one sentence what Dropbox does? Not all at the same time, please.
Files in the cloud.
Sorry?
Files in the cloud.
Files in the cloud? Yeah, okay, a little more. What does it allow you to do with the files in the cloud?
Sync them.
Okay, sync and share files in the cloud, right? So what do you think happened when, like, Drew Houston, who's one of the co-founders at Dropbox, posted his first prototype in 2007 to a techie forum? This happened. Why would anyone use this? If I have Linux, I can just come up with FTP, curl FTPFS, and then use SVN to sync that. Nobody needs this, right? So now I'm challenging you. Who can explain to me in one sentence what your platform does and why a consumer of your platform can just use an AWS account?
What?
Because the point of Dropbox was not that Brandon M could share files. He could clearly do that before. It was so that your parents can do that. If you don't know what Linux is, let's not get started about curl FTPFS. So that was a design decision. So the innovation of Dropbox was not in that it built something that was not technically doable before, but that it came up with a design that worked for its intended users. So let's make some examples that are not in the tech domain so much. So last year I was here on stage and talking about shared responsibility in the cloud and how we at meshcloud try to take responsibility for the carbon footprint that we cause by hosting software for you, right? And we have not fared too bad this year. Actually, what we did last year led to significantly reducing the emissions that we cause for hosting our production workloads, despite running a lot more compute workload than we did last year. So we're very happy about that. And I measured our success last year in saying that we saved as much that I can take my family down to vacation in the Alps with a petrol car for one trip. So we're still not saving enough, unfortunately, that I can justify driving a petrol car. So I'm shopping for cars, right? So here's what our good friends at Volkswagen have on offer right now. You can have a small car in red, which is like a Golf. We're a family of 5, so this is too small. This is one for like older people, I guess. And this is where the family kind of segment starts, right? The classic combi, and like this one, like the vans. So what does my personal transportation problem to do with the platform? So if you look into the data, you notice one thing. All of these cars are battery electric, rear-wheel drive, and have 210 kilowatts of engine power. And they all have a battery that's 77 or 79 kilowatt hours in capacity. Well, that's no coincidence, right? These cars are built on a platform called like the MEB platform, Modularer Elektrobaukasten. If you want to know more, you can ask Christian. He probably knows a lot more about that than I do. Let's look at what this platform does well, okay? So apparently it allows a car manufacturer to bring to market a lot of different models in different colors and shapes and sizes very quickly. It probably significantly reduces the barrier for selling a niche model like vans for families that don't sell as much as like Golf-sized cars, if you look into the numbers. And apparently the constraints that they chose for this platform are acceptable for like a wide range of use cases, right? Like with that car, you can apparently go far enough with enough power to go what the average buyer of these cars needs to do. So, can this platform do everything? No, it can't, right? Porsche Taycan, very nice car. It even has 5 seats, so technically it would work, but it's out of budget. And it's also built on a different platform. So, of course, you have to make choices when you design a platform of what it can do and what it can't do, and there's clear limits to it, and that's okay. Okay, so we still don't know how to design platforms properly, and that's because designing good things is very difficult and non-intuitive. There's no formula for coming up with good designs of things. But we can learn from mistakes, and we can learn from what we should not do. We had a whole session about pitfalls of building platforms, and I want to call out 2 pitfalls that I've seen a lot in building platforms, certainly. And that is, we nowadays have all of these cloud services, and it's very easy to build a platform, or a lot more easy to build a platform, because you can just compose like different pieces that you get from GCP or AWS or Azure. Well, just like in this picture, composing things together does not necessarily make sense as a whole, right? If you look at that watermill, you look at that edge here, at that wall, it seems to be running down. Like in isolation, that wall makes sense, right? The pillars here, in isolation, if you look at them, they make sense. But you compose all of them together and you get a perpetuum mobile. It does not make sense anymore. What I'm trying to tell you with this, if you're building a platform, your ultimate measure of success is whether your customers have success with the platform. That goes for the Volkswagen guys, right? For the cars, the ultimate success is not if people use that platform to build different models, but how well these models sell. That's the ultimate goal of the business here. And that's why it's important as a platform team that we don't lose sight about this relation and don't get overly attached to our technology and our orchestration and our Terraform and whatever, but that we look at, does all of the different pieces that I have in my platform, do they actually lead to a good result for my users? And the second is about illusions. So if you're abstracting away things, it's very easy to create the illusion that these things will keep working on day 2 when in fact they don't. So useful abstractions usually are those that provide something as a service and not just I will deploy it for you. So in the example here, that would mean not I'm just giving you walls and waterways and pillars and like a mill, but that would mean your platform maybe should provide milling as a service, right? You give me wheat, I give you flour. Very clear service. And then all of a sudden we don't need to worry about all of these problems anymore. That's probably a much better abstraction than letting people draw images that don't really work. Okay. That brings me to platforms of the future. And in this section, I want to talk about how I think, and that's a subjective perspective, of course, the usage patterns and the expectations that people have from platforms are going to change in the future. And for that, I want to look at the dreaded GenAI use case. How does a GenAI use case work? And that's very interesting, not from the tech perspective about the LLMs and like all of that fancy stuff, but about from a platform perspective, how these things work. So this is an example using Google Colab, which is their kind of like platform for developing and building these models. And you notice a couple things. It's running in the IDE, in the browser, sorry. The IDE is running in the browser. So I start off by default with a cloud-based toolchain, right? You can, with a lot of effort, bring your Java toolchain from your workstations into the cloud. That works, and that's great too. But with these things, we're starting in the cloud. The second thing is, I still need an API key, right? So I still need a Google Cloud project to run this, or an AWS account, or whatever the thing is that you need. So all of a sudden, I have a dependency on infrastructure that your Java development did not have. Your Java development needed just your local machine and a JVM installed on it. But now you need a cloud project and an API key that your users will lose, right? They're the source of all evil, right? Credentials. So, danger. And the third part is I also need data, right? So this example here is analyzing transcripts from the Apollo 11 mission, which was the one that brought Lance Armstrong and the guys to the moon. So apparently it's a very good use case for AI to figure out when they were joking on radio transmissions. That's what they're actually doing here. And for that, we need to have access to the data. So there's a pattern here, and that's one prediction I'm making, is that for platforms of the future, we are no longer just concerned by providing infrastructure and tooling, but that we also must look at how do we simplify access to the data that teams and people have to work with. And this will probably become a much more relevant part for platforms than it has been in the past. So how does this use case continue, right? So you're preparing a prompt, you're uploading the file into that, and then you're invoking this model with a prompt to get some answers. And what's interesting here is that this can happen in a lot of different ways, right? Here it's like with a Python notebook, you just click that button and it will actually issue the API calls and run that API against the model hosted by Google. So you're using a service. But it could also be running against your own fine-tuned model that you maybe host on your own compute infrastructure and your own infrastructure. So maybe all of a sudden you have analysts that not only need to run their workload, this like IDE and the notebook, but they also need infrastructure underneath. So some average dude that has a PhD in math now suddenly needs virtual machines on the cloud running GPUs. That's probably a challenge, right? To provide that in a way and in a way that it's secure. So what can we take away from this, from these platforms in the future? Well, the future is probably looking a bit like this, where you're actually not just having one platform that does everything, like the family cars and the Porsches, but you need to have platforms that come in sort of layers. So we at meshcloud have invested a lot of time in figuring out how to build good cloud foundation platforms and landing zones and these things, which if you look into platform strategy, they roll up under this term cloud-based platforms. So they're like the first layer that you have in the cloud. And then on top of that, you may be building a developer platform, like something for applications developed natively for Kubernetes, with the tooling and access to Kubernetes cluster and security and deployment pipelines, right? That might be a use case you have. But maybe you also have another use case, which is like a data platform where you're trying to get different teams to bring all of the data into a common data lake or data warehouse or whatever you have. And then on top of that, maybe you're building an AI platform that analysts will use who are not software developers to figure out how to build models and run machine learning and whatever. But the ultimate goal of all of these different platforms is that you need to somehow turn that into business. And this is where probably, given the current situation with the macroeconomic environment, a lot more pressure is on us technical people to highlight how our nice toys that we have on the CNCF landscape or whatever, how they contribute to actually enabling business, right? And it's sometimes very easy if you look at other examples like these car platforms to draw that conclusion, right? Like if you're building cars and you're selling cars and that's the business you do, so building a platform for building cars makes sense. But in IT, the chains of how does what we do contribute ultimately to a business process that generates value for the company is usually a lot longer. And that's where the challenge lies for us techies in the future, is to argue that value, to make it clear to the management stakeholders of how our platforms contribute to that. There's two other properties that I want to talk about what makes platforms successful. And these properties are that platforms should enable, ideally, their participants to benefit from other people already being on the platform. And that's typically achieved by somehow simplifying transactions that need to happen between those teams. So if we imagine, say, the Kubernetes developers who run all the workload there, you simplify, for example, switching from one team to the other if all use the same tool chain and the same CD pipelines and the same approach for building their containers, right? You can move your talent around from app to app a lot quicker. They can also easily find each other and talk to the application in the same cluster and don't need to have an external API gateway or whatever. You can make all sorts of additional benefits of making their lives easier because they're all running on the same platform. And the second is that platforms ideally create a cycle where if you're having multiple participants on a platform, and that's usually explained with marketplaces because there's such a natural phenomenon there that if you have more buyers, for example, you will also have more sellers on the platform, or vice versa, where you're creating this sort of effect. And this could be an example where nowadays many platform teams start as we're the only ones providing services on our platform because naturally that's the first use case that you're trying to solve. But maybe it makes a lot of sense that you open up your platform to others so they can also offer services on top of your platform to others. And that's, for example, if you're offering a cloud-based platform, maybe you can enable someone else to build a developer platform that has all of the developer toolchain, SDLC tools, etc. on top. That might not be your cup of tea or your core expertise because you're in ops and infrastructure and not in DevX. But you can enable these people to build a DevX platform on top of that, for example. All right, so, and as a closing to this talk about platforms of the future, maybe let's talk about what happened to Heroku as a platform of the past. I think it's a nice example of illustrating that because Heroku as the original past actually got bought out by Salesforce, which is the original SaaS tool. Like Salesforce was or is widely regarded as the company that invented the SaaS business model. And what sense does that make? Well, for Heroku, one of the challenges was that their customers had all of the data locked up into, for Salesforce. The problem was that their customers had all of the data locked up into Salesforce. So they were trying to build applications on top of that data. That was very difficult. So buying Heroku made sense for Salesforce because they could enable their customers to build these B2C experiences, they call it, like these apps that use the Salesforce data a lot more easily when their customers could not do that themselves before. And this is interesting because this is turning like a tech platform, which Heroku is clearly, into a business platform, like a basis for creating more business in the future for that company. And that pattern is actually quite common. SAP has the BTP platform, which runs on Cloud Foundry, and like Bosch has an IoT platform, and like there's like many different examples where tech platforms do this contribution. So yeah, if you take anything away from this, platforms of the future have to be focused more on business and less on tech. And I hope that was interesting for you. And we'll have a couple minutes for questions. Thank you for listening.